Why does Saturn have rings? What are the different types of clouds? What is HTML? Why does a tiger have stripes? Who invented fireworks?
Tell Me Why, the Video Encyclopedia, is a reference work that's designed to show the answers to questions that young people ask. All materials used in this work are based upon the best-selling book series by Arkady Leokham.
To know the planet, to know the universe, to find out what makes things work and why things are the way they are through observation, study, and experimentation. We can unleash the power of the universe and make almost anything happen. This is Understanding Science.
Anything that has mass and takes up space is matter. An apple is matter. I am matter. Hi, I'm Dr. Science. There are many different forms of matter. Some taste better than others. So, what is matter made up of? All matter is made up of simple substances called elements. Elements are substances which cannot be broken down into simpler substances by ordinary chemical means. Water is made up of the elements hydrogen and oxygen. Water is 2 parts hydrogen to 1 part oxygen. That's why we call it H2O. Ice, snow, and hail are all different forms of water. They're all forms of matter. Matter is identified by its physical properties. Color, shape, hardness, and odor are all physical properties. Everything that has mass and takes up space is matter. Is air matter? Well, to answer this question, first, let's ask ourselves, does air take up space? What do you think? Let's try something. It's filled with air. It does take up space. So, air, which takes up space, is matter. Now, there are 4 states or forms of matter: solid, liquid, gas, and plasma. To understand what makes each different, you need to know that volume is the space occupied or filled by an object. Solids have a definite volume and a definite shape. Liquids have a definite volume, but no definite shape. Here's 1,000 milliliters of water, and here's 1,000 milliliters. The shape changes, but the volume remains the same. So, water is a liquid. Gas, like the air in a balloon, has no definite shape and no definite volume. The 4th state of matter is plasma. Plasma has no definite volume and no definite shape, and is composed of extremely hot electrically charged particles. The sun, stars, are all plasma. Now, see if you can guess the states of the following matter. Is it a solid, liquid, gas, or plasma? What do you think? Now that you know what matter is, we can go on to something really heavy, weight and mass. Weight is the force that gravity exerts on an object. Our weight is measured by the force that gravity pulls us toward the Earth and the scale we stand on. My weight is 160 pounds. So, what exactly is gravity? Well, gravity is the force of attraction between two objects. Isaac Newton got to thinking about gravity one day when an apple hit him on the noggin. He wondered why the fruit fell down instead of up. It's just like when you throw a ball up in the air and it falls down. The ball, like the apple, falls to the earth because Earth's force of attraction for all objects. This powerful attraction is gravity. We know gravity attracts us and all objects to Earth. The fact is, gravity is not a force of the Earth alone. All objects exert a gravitational attraction on other objects. We just don't notice the gravitational pull between ourselves and other objects because Earth's attraction is so much greater. Earth exerts more gravity because it's so massive. So the greater the mass, the greater the gravitational attraction. I have a different weight when I stand on a mountain, in a valley, or on the moon. If you weigh 100 pounds on Earth, you weigh less than 17 pounds on the moon, 1/6 of your Earth weight. On the massive planet Jupiter, you would weigh 2,700 pounds. So, if you're planning on taking a trip to Jupiter, you might want to consider going on a diet first. Now, even though your weight changes in different locations, no matter where you are, your mass never changes. Mass is not the same as weight. That's why it's more difficult to push a shopping cart full of groceries than it is to push an empty cart. Whether the cart is empty or full, the mass is still the same. But the weight of the full shopping cart is more than that of the empty shopping cart. So the weight can be different, while the mass of both carts still remains the same. Mass is a measure of the inertia of an object. Now, here's an experiment to demonstrate inertia. If you have a glass, a playing card, a coin, you can try it with me, or you can write this down and try it at home tonight. First, place the glass on a table. Then lay the playing card on top of the glass and put the coin on the card. Now here comes the tricky part. Use either a flicking motion or a pulling motion of the fingers to quickly remove the card so it flies out from under the coin. If you get good at it, you can remove the card fast enough so the coin lands in the glass. Inertia is what we call it when the coin at rest resists a change in the motion and remains at rest. Try this with coins that have different mass. The more mass an object has, the greater the inertia. Mass is measured in units called grams and kilograms. 1 kilogram is equal to 1,000 grams. And you can use a balance to measure mass. Now let's try an experiment in density. Take a marble made of glass and place it on top of a container of water. The marble falls down to the bottom of the container. Let's look at that again to see what happens to the water level when the marble is dropped in. Which has the greatest density, the marble or the water? It's the marble. We know that the marble has greater density because it sinks to the water. Now you may wonder, how do you measure density? Well, density is the mass unit of volume. To find density, you must be able to measure mass and volume. What would happen if you dropped a piece of lead into water? If you think it would sink, you're right. Now, which one of these substances do you think has the most density? Aluminum? Gold? Ice? Steel? or water? Gold is the most dense. Now, what is the next most dense? Steel. Now, out of aluminum, ice, and water, which is the most dense? Aluminum. Of the two left, which has the most density, water or ice? Now, there's a tricky one. Remember that ice floats, so it's less dense than water. So, the general properties of matter are mass, weight, volume, and density. Matter is also described by its physical properties such as color, shape, hardness, and density. Let's try an experiment to show how physical properties in matter can be altered, but the substance of the matter remains the same. Physical changes do not change the substance of matter. Take the stick and break it. Now, take the paper and tear it into pieces. When you put a sugar cube into warm water, it dissolves. Physical changes alter physical properties of substances, but the substance remains the same kind of matter. The wood is still wood. The paper is still paper. And even though the sugar has disappeared from the sight, the sugar is still sugar. You can taste it. Taste is another physical property of matter, but it's very dangerous to use when identifying substances. So, never taste anything in a science class. Okay, this next experiment will tell us how closely the particles of matter are arranged in a solid or liquid. Fill one container with marbles, one with sand, and another with water. Now, look at the beaker filled with marbles. Do the marbles occupy all the space in the beaker? Carefully pour some sand from its beaker into the beaker of marbles. How much sand fits? Does the sand and marbles now occupy all the space in the beaker? Well, to find out, slowly add some of the water from its beaker. How much water can you add? The marbles didn't fill all the available space in the beaker, and the sand we added filled up the spaces between the marbles. The liquid filled even more space between the particles of sand and the marbles. So there is space between the particles of a solid and a liquid. Now that you understand the physical properties of solids and liquids, it's now time to examine the behavior of gases. We can only do that by learning the gas laws. Now, although you cannot see gas, their particles are in constant motion. Each particle collides with one another about 10 billion times a second. The gas particles also collide with the walls of the container. The effect is an outward push or pressure by the gas that makes it expand to fill its container. This is Boyle's law. The volume of a fixed amount of gas is inversely proportional with the pressure of the gas. In other words, if the volume increases, the pressure decreases. Charle's law states that the volume of a fixed amount of gas is directly proportional with the temperature of the gas. If you put a balloon in the freezer, what happens? A decrease in temperature results in a decrease in volume of the gas inside the balloon. An easy way to remember Boyle's law is to think of it as an inverse proportion. As one factor increases, the other decreases. Charle's law is a direct proportion. As one factor increases, so does the other. Charles and Boyle's laws explain the behavior of gases related to volume, pressure, and temperature. Now, let's see if you know the differences. Is this an inverse or direct relationship? The greater the number of hours worked, the more money earned. Direct. Now, try this one. The greater the number of cars on the road, the greater the chances of an accident. Direct. The more people that play lottery, the less chance I have of winning. Right. Inverse. Plasma is the rarest state of matter. It's very high in energy. In fact, it has so much energy that it's dangerous to living things. We already know that matter is classified by 4 phases: solid, liquid, gas, and plasma. On Earth, matter occurs naturally in only 3 phases: solid, liquid, and gas. If ice, water, and steam are all the same substances, what causes the particles in one particular phase rather than the other? What makes ice ice? What makes ice water? What makes water steam? The answer is energy. Energy is the cause of phase changes in matter. Each phase of matter has a different amount of energy. In the gas phase, a substance has the most energy. The same substance in its liquid phase has less energy than gas, and in its solid phase, the substance has the least amount of energy. Phase changes occur either when energy is gained or when energy is lost. When you're burned by steam, the burn is more serious than when you're burned by water, and that's because the steam has more energy than hot water. So, by increasing or decreasing energy, phase changes are caused in substances. When you put water into the freezer, you remove heat or energy to make ice. You add heat energy to turn water into steam. The phase changes in matter are melting, freezing, evaporation, and sublimation. These changes in phase represent all physical change. Melting changes a solid into a liquid. When vaporization takes place at the surface of a liquid, the change is called evaporation. Evaporation is a cooling process, as when your body perspires. Boiling causes particles inside liquid to change to gas. These particles travel to the surface of the liquid and then into the air. When a substance in the gas phase, such as steam, loses energy, condensation turns the gas into a liquid. When a substance turns from a solid into a gas without passing through the liquid phase, the change is called sublimation. Dry ice, which is solid carbon dioxide used to keep things very cold, cannot exist in the liquid phase. As it absorbs heat, energy, it sublimes directly into the gas phase. Remember, when a substance goes through physical change, it remains the same type of substance. The chemical properties of matter describe how a substance changes into other new substances. Now let's see how chemical changes are different from physical changes. You'll need beakers, citric acid crystals, baking soda, and water. First, combine the citric acid crystals and the baking soda. This is a physical change. The two substances simply mix together. Now add water. This is a chemical change. The water causes the two substances to dissolve and react chemically. This is why some dry goods are marked, "Store in a dry place only." The many different properties of matter help us to understand why things are the way they are. So, again, here are some of the things we learned today about matter. Anything that has mass takes up space, it's matter. Matter is made up of simple substances called elements. The physical properties of matter include color, shape, hardness, and odor. There are 4 states of matter: solid, liquid, gas, and plasma. Matter is also described by its general properties: mass, weight, volume, and density. Gravity is the force of attraction between 2 objects. The greater the mass of an object, the greater its gravitational attraction. Weight is a measure of gravity's attraction on an object. And though your weight may change in different locations, mass remains the same. Mass is a measure of the inertia of an object. When an object at rest resists a change, it remains at rest. Volume is the space occupied or filled by an object. Density is the mass per unit of volume. Physical changes may alter physical properties, but the substance remains the same kind of matter. Phase changes represent all physical change. Phase changes occur when energy is increased or decreased. The nature of gases are described by 2 important laws. Boyle's law. If the volume increases, the pressure decreases. Charle's law shows us that the volume of a fixed amount of gas is directly proportional with the temperature of the gas. Chemical properties of matter, unlike physical properties, describe how substances change into other new substances. Understanding matter and its physical, general, and chemical properties helps us to better understand the world we live in and more complex scientific ideas. See you again as we continue observing, studying, and experimenting in understanding science. Bye.
Tell Me Why is a series of educational programs based upon the popular book series by Arkady Leokham. To order or for more information about this or any other Tell Me Why program, please contact TMW Media Group.